Hello students, today we learn the Modi method, that is modified distribution method. This method is used for finding optimal solution for transportation problem. First find initial basic feasible solution and then we find optimal solution. For finding initial basic feasible solution we learn three methods. First is northwest corner method, second is matrix minimum method, and third is WAM method, that is Vogel's approximation method. For finding initial basic feasible solution, for finding allocations, then after that we will solve Modi method by finding optimal solution. Okay, sometimes the theory is given or question on theory in your question paper for 5 marks, that is explain the Modi method, that is modified distribution method. Okay, today we learn the theory of that. First step, construct a transportation table entering source capacities, destination and cost. That is our transportation table, given transportation table for right there in sources, capacities, destination and all cost of the transportation problem. Step 2, find an initial basic feasible solution by any one of the previous method. For finding initial basic feasible solution, you know that very well, we solve this by three methods. Okay, northwest corner method, matrix minimum method and WAM method. Then step 3, it is most important step. In step 3, for occupied cell, occupied cells means where the assignment is given. That means suppose there is a transportation problem, here occupied cells are 1 cell, 1 2 cell, 2 cell, 2 3 cell, 3 cell and 3 4 cell. These are occupied cells, and non-occupied cells means the assignment is not given in that cell. That is here 1 3 cell, 1 4 cell, 2 1 cell, 2 4 cell, 3 1 cell and 3 2 cell. These are non-occupied cell. See the difference between occupied and non-occupied cell. Occupied cell means the allocations are there, and unoccupied cell means the allocation are not in that cell. Okay, next occupied cell साठी which calculations will be find? First calculation for occupied cells, ui plus vj equals to Cij. Cij means cost of cell, ui means number of rows, vj means number of columns. Means suppose we find for this occupied cell, that is this cell is C11. Okay, you find the formula ui plus vj. Therefore we write C11 equals to u1 plus v1. For all cells we find such a calculations. Okay, for occupied cells. Starting now, for finding these calculations, starting with ui equal to 0. For finding the values of ui and vj, starting any one ui equals to 0. Thus we get all values of ui and vj. Mostly we put which ui equals to 0, the number of allocations are most in that columns or in that rows, we put these ui equal to 0. Okay, next step, step 4, for unoccupied cells find the cell evaluation. Which evaluation we calculate for unoccupied cell? Dij equals to Cij minus ui plus vj. We calculate Dij equal to, means suppose we find this cell D13, we calculate D13 equals to Uij. Uij means U13 minus, sorry, Cij minus, Cij means C13 minus U1 plus V3. We calculate this and then we find the value of Dij, that is D13. Dij equals to Cij minus Ui plus Vj. Next step, apply optimality test by examining the sign of each Dij greater than or equal to 0. Optimality test. What is optimality test? Optimality test is if all Dij are strictly greater than 0, the solution is optimal and unique. If all Dij is greater than equal to 0, then our solution is optimal and alternative. And if at least one 0, any one 0 is negative, that is Dij is strictly less than 0, then our solution is not optimal. Then we see all Dij, finding all non-occupied cells Dij, then check the conditions, which condition is there. If all Dij are greater than equal to 0, then our solution is optimal there. If all Dij are not greater than equals to 0 or strictly greater than 0, solution is also optimal. Less than 0, then our solution is not optimal. Then we go to the next step. If our Dij is less than 0, then we go to step 6. Now see, make a loop. We make a loop there. Assign the quantity theta in the home cell, means see which Dij is negative, then this cell is your home cell, and accordingly we take the values minus theta, plus theta, minus theta, in that way. Select the minimum quantity Xij in such a cell with minus theta and revise the transportation schedule. See there, suppose there is a loop, okay, then we get this is home cell. Here minus theta, plus theta, minus theta, plus theta. Then see these two values. Which value is minimum? Suppose in these two values, take the minimum values and it is equals to 0. We get the value of theta. Okay, we select that value of theta. We see this in example. Okay, step 7. Now evaluate the transportation cost. You know that very well how to calculate the transportation cost. Allocation into cost of matrix. Okay, for improved solution. Then step 8. Repeat the same process from the steps 2 to step 6 until an optimal solution is obtained, that is Dij greater than equals to 0 for unoccupied cells. For unoccupied cells, Dij is not equals to 0 or greater than equals to 0. Then repeat all the steps from steps 2 to 6, means again find the optimal solution, again find the initial basic feasible solution, again find the calculation for occupied cell, again find the calculation for unoccupied cell, again check the conditions Dij are greater than equals to 0 or not. If all Dij are greater than equals to 0, then our solution is optimal and this transportation cost is our optimal solution. Okay, thank you. We see in another video one example on Moti test. Thank you.